Hello guys, welcome back to a new video. And in today's video this is the part 3 of the projectile motion, and we'll be focusing today on the formulas related to projectile motion and understand the concept. In the previous video we have learned a lot. If you haven't checked out the both parts, previous two part 1 and part 2, do check that out to learn about the motion in 2 dimension and the projectile motion basics. I'm just copying or moving this definition over here because our primary focus in this video is to focus on this. uh, I've got a wonderful diagram for you as well that will make you guys more clear about the topic. Okay, so projectile motion, yes, for understanding the projectile motion, as we have drawn this thing over here, I can take this one as well for making you guys clear. This is just a topic based on uh, diagrams. Okay, so here it is. Now in this picture I have shown you guys that we have got, do recall the previous video if you have watched, and if you haven't watched, do watch that out because that was the base video. Now in this video if you look, uh, we have got the factors that every projectile motion will have an initial velocity that is denoted by v naught, and at the final we have got the final velocity that is denoted by capital V. We have discussed this thing, and now what we are doing is this. The object from the point of projection, as I told you before, the point and angle of projection in the last video. So the point of projection is placed with respect to the angle and the force applied, and of course the force has a direction. In this video we can see that clearly we have got direction. We have got direction in this direction. It is showing like the ball is moving and you can see the direction, and I will explain you this figure very soon. Like, first of all we need to make the base. Now consider this ball. Yes, this one. Consider this ball or the ball at any place into this projectile motion and resolve it. If you haven't checked out my video of resolution of a vector, do check that out because the resolution of a vector is being used over here. Now this is the ball, this is a ball, and this ball is moving in this direction, right? But we need to dissolve its factors, and the factors would be like this: Vx in the x-axis and Vy in the y-axis. This is the resolution of a vector Vy, right? Now remember this, that in the projectile motion, in the x direction, means like the horizontal direction, we have got air friction. Air friction is there. Air friction is there. But we neglect the air friction. This is very important point that you need to know. We neglect. Sorry, this was not in this place. I'm just moving it. Let's just write it up so that it gets more clear, because there seems to be a theoretical point over here. X-axis. If you simply see on the x-axis the horizontal plane, this is the axis I've seen you guys. So in this direction, which force is being applied on the ball? That is, you can say that what resisting force is applying on the ball. You will say that that is only the air friction is there. Now axis, air resistance. Air resistance is present. Air resistance present, but in projectile motion it is neglected, right? This is a scene. Like in this, what happens is this, uh, we just neglect the air resistance in the projectile motion. While if you see here, I'm just making it with the diagram. This, there is air flowing, this is air flowing, but there would be no impact of air. While there would be a gravity attracting it in the y direction. I was talking about this. In the x direction you have got there are two resisting force which are making this ball come back down, otherwise it will go up till without any it will go up because there is no friction there. That would be smooth and surfaces, but air friction is neglected, but instead there is a gravity, and gravity is of course playing its role. Now in the y direction, let me make it more clear to you guys, hopefully now you will get it. Y axis, gravity is present, gravity is present, right? Okay, so as I said, the air friction is neglected in the projectile motion. This means that uh, this means that this means that there is no acceleration, because the uh, for suppose there is a ball, and uh, let's just break its forces, its velocity in two direction, in x-axis and y-axis. So in x-axis, uh, there is no any sort of resisting force. Air resistance is neglected, so there would be a constant velocity and there would be no acceleration. No acceleration. This is very important point, and there you will the basic concepts of projectile motion. And if you're not understanding these things, do watch the PS part because they have got link. No acceleration, and this means that there would be no acceleration, as there would be uh, constant velocity in the x, constant velocity. We're understanding these things with the diagram as well. In y-axis we have got uh, gravity, a resisting force, so that means that there is acceleration. Acceleration is there, and acceleration means that there is change in velocity. Like you can see, the ball will go over here, then it will go over here, then it will go over here. The this is gravity making it to change its direction. It is going up, and due to gravity, the highest peak point it is again coming back down. This is not due to air friction. This is due to the gravity. Okay, so acceleration where there is a velocity, uh, change velocity, change in velocity, change velocity, and this means that here what would be the value of the acceleration? That would be 9.8 meter per second, because there's a gravity acting over there, meter per second square. Right, this was the whole concept. uh, you know Now what we're gonna do is this. As you know that v naught is the initial velocity, and uh, now we have broken the axis. V naught x, v naught x, we have made this, and we have made v naught y. uh, so initial horizontal velocity v naught x is equal to, as we know that we resolve a vector, we can say that v naught cos theta. Now this is again relating to the vectors chapter. If you haven't checked out those videos, do check them out. You will get to know. This is the the resolution of vector. In the composition of vector, you get to know it. V naught cos theta. This became the formula of v naught x, means the x direction. The x direction velocity, initial velocity, would be equal to this, and v naught y, v naught y, that would be equal to v naught sine theta, v naught sine theta, sine theta. This is how it works, and of course we do know that v is the final velocity. And now in the next video, hopefully this is good till this video. In the next video, hopefully we'll be looking into more formulas of the horizontal motion and the vertical motion, the velocity, acceleration. What are the formulas. This was just the introduction of the forces resolution in projectile motion. Like I was just making you explain this thing. Now look at this diagram finally. uh, this was the ball, and now v not v x is v x I, v initial I, v not x is this, and v not I is this. And you can see that this is in this direction. Now this gets in again resolved. Now uh, at the peak point you can see that uh, that is the position where the ball stops at certain point, and vy over here is 0, and vx is, we are understanding this thing, why this thing happened, and gravity is playing its role downward. And again, we have got resolution of vectors throughout the projectile motion, and by the help of this we will be driving more formulas of horizontal and vertical motion, hopefully. And if you are thinking why we have not got this one sign over here, we'll be talking about this as well. I'm talking about this, why this is not present over here, because there is a reason behind it, and hopefully when we complete uh, the next part or upcoming part, you will probably get to know about it. So that was it about today's video. Meet you guys in the next video. Till that, goodbye.